Okay, ladies and gentlemen, what I did was, which did not happen in real life, the bar totally removed. Under the underside of this deck, in the lower section of the diaphragm, I put a post-tension bar, singular post-tension bar, singular action down the center of the deck. This is now crowned. The amount of post-tensioning I put on there crowned it to some degree. We'll use this. This is pretty flat still. This one is corrupted now because a couple of my testings I now deformed it, so I have to make a new one, but a new indicator for us. But watch the deck still without the post tension, with number 11 removed. Where, of course, previous videos you should know now that it's going to deflect. It's going to break where it broke in the true video. And we have our model here. This is George. Let's get George in here. George is inspecting. And George, you finish your inspection? Apparently so. Okay. So now watch the model as I load it. Now remember my resistant forces now are in this bar. I'm doing, you know, it was up here in the deck, but I have it at the bottom now. This just stops that kick out that I showed you. It would also stop the kick out if they had the bars in there as planned, tied to the pier. But now let's use it with number 11 totally not in the picture because of the cracks show such that there's really not in picture's intention, the failure cracks. I'm going to show in this video, I'm going to weld into the deck to capture, as the OSHA report states, Denny Pate wanted to capture nodal 910 node back to the diaphragm. Bridge, OSHA report. Allow me to read this. FIG did not know the reason for the cracks, but still expressed no safety concerns. However, FIG in his presentation alluded to a lingering concern about the structural inadequacy of the 1112 node until the temporary pylon and back truss were completed. FIG mentioned a temporary mechanism to capture the nodal zone. The quote nodal zone, but look at the nodal zone. Listen on. FIG opined that it may be appropriate to transfer the loads, some of the loads off of 1112 node. All right, off of 1112. FIG was to consider options to capture some of the forces from the node. FIG also stated that quote prudent action is to share some of the load carried back to 910 and construct a pylon diaphragm. So the pylon is specifically a pylon diaphragm. FIG further proposed, quote, restrain the node. So restrain the node. FIG promised to deliver the temporary mechanism to capture the forces in node 1112, and it says and, not of a load of node 1112. It says the forces and node 1112 by March 17, 2018, 2 days before the collapse, 2 days after the collapse. To MCM in 2 days, showing a sense of urgency. FIG rightly recognized the structural inadequacy of node 1112 and presented remedial measures to capture the loads. Restrain the node, as now he's saying restrain the node there, talking about 11 and 12 this time for clarity. And share some of the loads to the node 910. I'm going to show you in this video that the nodes, all the loads are now 910. That 11, it's acting like a tie-back truss system, which I had some conflict with a couple engineers that don't see it that way. But okay, you got to bear with me. I think you'll see it, or you're never going to be able to see it. But at no time did FIG recommend the shoring of the bridge at an intermediate location of the span to reduce loads in diagonal 11. So at no time did FIG recommend the shoring of the bridge at intermediate locations, S. I'm going to show you only have to put it in one location to capture it, to capture these loads, to make this bridge structurally sound. One location. It's going to come up in a video. And I'm going to show it to you on my model with me loading it. Of the span to reduce loads in diagonal 11 and nodal zone 1112 and closure of Southwest 8th Street. Okay, it wasn't closed. All right, so you can see they're talking about 9 and 10. Let me go ahead and jump back to the video now. I just wanted to get this. This is a B-roll, and then I throw it into the video. I'm going to show something of this nature welded together and show you how that would work. I'm also going to show you in a few moments how a temporary support, the Denny Pate, was reported to state it would only give a false sense of security. If we put a temporary support under 910 node, that we would get the effect of saving the structure. I'm going to load this partially with my weight. I don't know if I'm going to make it to full weight, so let me brace myself a bit. All right, so I did make it to full weight, and you see the kick out. Is it riding on that down there? I can't tell, but that's full weight. And you see where the deflection is taking place, here and here. Now, if I were to, I would not be, that was full weight, that showed the deflection, not in the middle of the deck, but the resulting out here. Again, if they would have the enough post-tensioning, though, I believe, that worked to calculations to stop the deflection, this would have never happened, even without this being this redundant or redundant factor, if you will. This is weird. It's a weird system. So this would be acting as a strong back if you're double dipping. One is a canopy for the protect the people, decorative columns, diagonals, and everybody walks on the deck, and all the loads are transferred to the deck. I was doing a video and I didn't load it up yet, but I found where in those reports where, and it was Denny Pate's engineer report stating the counter report against the NTSB report, how Berger's engineer, singular engineer, stated the pipes, even though the pipes were pipes and not cables, he was still going to count them as a cable stay bridge. And that's just ridiculous, right? The anchoring here is only in bolts. Just some bolt connections here, and bolted connections at the pier, at the tower. At the mid-support tower. They're just bolted connections. They don't have the capacity to hold up a structure like this. That's ridiculous. Plus the dead load of that steel is a dead load on top of the structure times whatever it is. Okay, so let me now segue into this, how I understand the load path of the structure based on the post-tensioning, not on actual computer models, but on the intent of the post-tensioning here. Let's look at this. This was designed to be removed, this post-tensioning here. So if it's designed to be removed, and this is all concrete, we don't want concrete in tension. Every amateur knows that, right? So even everyone, including the amateurs, know that. So that means that this is automatically a compression member. And we also would say that of number 11, that it would be in compression, that you wouldn't see any tension breaks in this because they're going to remove the post-tensioning in here, which means, well, it's a compressive member. Look at number 4, no post-tensioning at all, or number 9. So 4 and 9 are just pure post-compression members. Now, this one, number 3, let's think about that. So as the bridge is falling, sagging in the middle, let's call it, that would imply, if you could just make this sag, let's just talk about a sagging in the middle of full length. That means this would be under tension, breaking apart. And we can't have that. The bridge wouldn't like that. You don't need to break apart. So what do? You put the post-tensioning bars in here. I think this is times 4 on the B. B has, look over to the right here, my mouse is. B has 4 post-tension members in it to the tune of 280 each or something like that, 280,000 kips each. So, it's like over 1 million pounds of force inside this member here. Clamp force from here to here. So as this bridge tries to push down, it can't separate these two from the canopy to the lower one as it tries to sag down. So it now it redirects those forces to the top of the nodal area here, which directs them down too in compression. And now we're back out to the diaphragm. Awesome. Same thing here. Now we have this member is a tension member because it has post-tension bars in it. Let's see what it looks like with their theoretical. Where you see, double C over here is 2 post-tension members. So they're experiencing similar to 11, theoretical 11. Not at all, because this is a totally active system. It's working all the time under dead load. And this was non-active theoretically non-active once they loaded it on the piers. So once they remove the scaffolding, this now becomes, if you didn't have this in here, these bars, this would break apart. So what keeps them from breaking apart? Again, you put 2 post-tension bars in there, clamp them together, and now as this tries to create tension, it can. It keeps together, redirecting, right? So you see the redirect? We have D, that's a single, right? D is a double, turned the other directions. My apologies. So same thing, D. Same thing with 7. There's 8, and you see 8. And 9 is just compressive. There's nothing in there. So we can see theoretically 9 was working. We don't see any cracks in 9 as the bridge failed. So the theoretical model, this worked out. And 11 has the post-tension bars completed. They never detensioned that, so that always was under compression. Save that they had some fine cracks up here, which to me means those fine cracks appeared when they remove the shoring. Shows that, yes, these may be a huge amount, 1,000,000 pounds, etc., but yet cracking appeared. Fine may they be, but nevertheless, this concrete did not remain totally in compression. It was the bars were holding this thing up from top to bottom. So I state that Denny Pace design is still awesome. You know, it held together down here at the nodal designs, holding this together. Clearly, concrete's not holding together. You don't use concrete in tension like that, right? So the bars are holding it together, but I think they're undercalculated, because I would imagine theoretically you shouldn't get any cracking, fine may they be, inside these members. Cracking represents elongation in the cables, which means, you didn't quite get it, did you? Or did they count for that extra bit of elongation and said that's good enough? But that elongation would also cause sagging in the deck, which changes this to a non-compressive system, and sagging in the canopy, which this system works under compression all the way, not with sagging taking place. All right, I'm going to make this just a B-roll again, so let me throw this in and keep it going. Oh, wait a minute, let me finish that. So 9's in compression, 10 is so 9 is in compression, the loads go from here, as you'll see. They come out to here. All this didn't make it. This didn't make it. So if this was falling back, right? So this is compressive. So this means this would have been a tension member. If this is a tension member, that means it's opening, O-P-E-N-I-N-G, opening and capacity. If they put a 10 in here, by default, if this is opening, this has to be a compressive member to get the forces out. And they assumed that when they detention, and then they found out, oh, shoot, this is not a compressive member. It's a tension member in this design. It's opening up here, which now means the forces are resolving themselves at 9 out to here. And I'll show that in the model. And that's what I'm saying the tie-back version of the structure works, like a tie-back bridge, is that this would have then re-anchored it from this being the top of the structure, would have pulled it back, re-anchoring it back into the diaphragm in compression, taking the tension out. And that is where this whole thing is. It's just wrong. The engineering was defective. How's that? So again, the opening of it shows it was in tension. It limited its opening because the bars were still there. It rebid on the nuts, and the nut up here, because it's the one they loosened. It didn't. So just rebid on these nuts, literally, not these down here. These are the ones they adjusted, upper and lower. That stopped the bridge from collapsing fully, and that created that tie-back effect. And then they try to tie it back up, shorten this length again by post-tensioning again, retensioning, and that would have had the effect of lifting up on the structure. But they couldn't do that because the weakest part of these nodes now were this lacking node down here, especially because of the cracks. Then also show in their computer model, it doesn't make sense. The computer model run by Berger is that all these they show all this deformation, but they show no breaking of any of the pipes or the deck. This is a solid member. You can't get deflection like they performed on this entire profile. Maybe I'll be able to show it to you in the video. Maybe it'll be another video. That they did 150 times magnification and amplification, and they never showed a single break in this. I thought that was ridiculous. That you extrapolate out that far and you have no breakage in your system. Alright, so you saw what happened there. It's still here and here. Now let's go ahead and put a temporary break support under 910 node and see how false that would have been if you said a temporary support would have just given a false sense of security. Let's do that now. This will also tie into the criminal charges that possibly might still come about. That who is negligent here? And I would argue. So I would argue lack of shoring the structure is the negligence that all they need to do. That's it. Just lack of shoring would be the negligence that caused deaths, that resulted in deaths. As simple as that. They would not be able to argue against that, I don't think. Now, to get ahead of myself, my brain, you guys know that all of them were negligent. Every single engineer that was there that had authority were all negligent. They should have all spoken up. The person who said temporary supports should have spoken up. Now, can you argue that I didn't quite follow what Denny Pate was saying? I was just going along for the ride. I didn't have enough time to absorb it and process it and figure out if it was true or false. Can you make that an argument where you're representing the state, the guy representing the state? How can he make that an argument? I don't know if he was representing FDOT, which has authority to shut down the road. So I would say FDOT would be responsible also. But FDOT is also a state. It is the state of Florida. And so how can the state prosecutor who works for the state of Florida now all of a sudden put charges on the state of Florida? I don't see that happening. So these criminal charges, it might be just academic BS, or they might not charge the state well, they won't charge the state. The state doesn't charge itself, right? So they charge someone that's negligent, but they won't charge someone in the state. So they won't charge the state itself. The state of Florida versus the state of Florida. That's not going to happen. So the state of Florida is going to get a pass on it. And that means automatically the federal highway gets a pass on it. So then we have FIU, FIG, Denny Pate. VSL clearly claims to be part of their structural analysis and repair company for structures such as bridges. They should not get a pass on it. They should have known that these cracks were structurally. They should have had their own person dealing with these cracks. Their own engineers saying, "No, we're not going to be post-tensioning something. We think your analysis is corrupt." But clearly, they did not do that. We're talking small change money too that they went forward. MCM also gave the authorization for VSL to do that. So MCM had engineers there too that should have spoken up. So yeah, I see that you could find some negligence in there, and quite a few of them. Let's specifically, since it was talked about specifically, remember, I'm trying to think criminal charges wise how you would be able to prove it in court of law type thing. You would say, well, the supports were brought up and it was all decided by everyone in there because no one said, I'm going to put it on record that it should be there and I'm against what we're doing. No one stated that, but it was brought up that temporary support should be added, and no one insisted it. So I'm going to show that a temporary support would have resulted in probably no loss of life. Let me get my piece of metal right back. So now I'm going to add a piece of steel. Call it number 10, 910 node. It's the same depth as that. I'm going to add a little twist to it. I'm going to remove the post-tensioning bar again that I placed. Okay, so to the right, this is showing that this is elevated higher. Same amount of steel, but I'm showing you what a temporary support would be. This holiday's under there, as you can see. So it shows it's not resting there. So we have the whole entire structure now on a temporary support, if you will. trying to see if I can get better lighting. That's what I use for better lighting sometimes. So on a temporary structure, if I stand on this, what will happen? Well, I haven't stood on it yet. This will be the first time. But I stand on the position that, well, all the loads will be going down 9, 10. And this would just be in a cantilever, but in reality it's touching there, so it would be supporting from this support to here. They would be sharing this load only. Remember, I have holidays there. This is all cantilevered at this point. From here down is cantilevered. See, being that it's cantilevered, we don't have to consider it as part of the load path. It takes away from some of the capacity, but that's on the cantilever's end of it. Now watch what happens. Nothing's going to happen. It's going to take my load. It's going to take my load fully, and it's going to go down 9, 10. As you can see. So temporary supports right under 9, 10 would have saved the structure. I mean, you see loading that. So to say it's to give a false sense of security is wrong. 9, 10 are where the load paths are going, which I keep telling all you guys. If I go here, if I move this back to here, it's now going to have a deflection of failure. It won't happen. I mean, what will happen? It's still in failure mode. The loads are down 9, 10. No magic trick. No magic trick. I can use my hand loading now, and you'll see the deflection happening out here. As you can see in the holiday there. Let's zoom in on it. As you can see in the holiday happening there. The deflection here and here. So that's why I keep insisting that the loads have changed. I've always said that from the beginning. You guys always said, I don't know what they're talking about, that crap out there. The loads are going down 9, 10 and resolving themselves that direction. And now you see I totally removed 11. So, really? And we don't see the loads are here now. Now let's go ahead for a little bit of non-fairness, because it wouldn't be fair. This always have to be, the loads will be going here. If I make this even, you watch the deflection down there. You see you get no deflection. It doesn't go up. It doesn't go down. There's no change in the between these two as I load it. Watch here. There's no change in there. If anything, number 12 might do something, but I don't think it's possible. Let me think about it. No, it's not possible. 12 shouldn't even go up. 12 shouldn't have, unless, you know, I'm vibrating it. That's about it if I'm vibrating it. But we'll get no reaction. So 9, 10 is your load path that I keep screaming about. But that's where the loads are where it would have temporary supporting, would have saved the structure under my modeled programming here. That 9, 10, the loads are going down there. Removing that indicates where they really are going from 9 out to there. If this was only supported there. I guess that's all I can really share with you at this time. I'll give you another video, more videos, but I'm showing we have no post-tensioning in there. It doesn't count. I'm just showing you temporary supporting would have saved the structure. Shoring, I think, would have saved the structure. And you saw I removed the bar under there, the post-tension bars. It just changes the load path. Now, I have to consider that that you can't do anything here, though. You can't raise it up one bit. You can't lower it down one bit without creating a new load path. Because remember, this is post-tensioning, and you could change a profile if you were to be able to flex this bridge up. And we don't want to flex it up, you don't want to flex it down. It's already in a down capacity. It's already got sagging, and I believe the sagging would be presented right here between 9 and 10. All right, and remember, they extended this bridge by 12 feet. I just wonder how much engineering took place, and I can't find it. I'm waiting for NTSB to get back to that. How much new engineering took place when they extended the bridge? How much new post-tensioning took place, etc., from the 175 foot to the, from the minus 170, 12 foot from 175? Or were they not that far in the engineering at that process? Just wondering. All right, I'm gonna load this up for you guys and show you that again. temporary shoring down 910 would have saved it. I was going to do a video and show you how you can recapture this another way also, by welding this in here, welding that there, welding another one here, tying them together at the top, and showing you that that would also recapture the forces from here out to here, out to the diaphragm, bringing the forces out to the diaphragm. That should be another video to show you that Denny Pate said that in the OSHA report. States that he wanted to recapture forces from 910, well, out to the diaphragm is where the only place you're recapturing them to save the structure from here to here. I think that Denny Pate knew that this was intention, that this wasn't a slide issue and the loads were really here. But everyone else there didn't quite conceive it. And I think the guy's pretty smart, so he didn't really want to, try to educate these idiots, I guess. And just said, look, just trust me, this is going to work. But this is where he dropped, where his arrogance, or his illiteracy, ignorance, dropped the ball, screwed the pooch. He didn't want to temporary shore it. False sense of security is what one of the OSHA reports had in it. It's not in it, the current one, but it was in one, so I can state that, and it's not liable because it was in one, and I do have a way to prove that. But that, you got to see me in court to get that evidence. So there we are. There we are. There's your load path. All right, I'm going to load this up, and I'll get you more. There's more to this. I'm going to slowly work up to it. But guys, it would take me hours to really go through each one again, answer every question. So I'm just doing the grouping of data, and that way you guys can catch up and start adding it all together with little questions instead of an 8-hour video I may do of it, which I did 8 hours videos before, if you guys remember. And then I just make them private after our 8-hour chats. Okay, moving on, you beautiful people.